Hello everybody and welcome back to another episode in this Pygame tutorial series. In today's episode we are going to be creating an enemy for our game. Now in the last episode we built a cooldown for our shooting mechanic, and so we're moving on from exactly where we left off last episode. Over here in the editor I have the code which should be familiar to you if you've been following this series from the beginning. I've sort of minimized the classes that we're not going to use today, just to make it easier to understand when I'm making changes to this. So, since we want to add an enemy to our game today, the first thing that we're needing to do is we need to add some images of an enemy to our game. So the images we're going to use are going to be linked in the description down below with the corresponding credits. And we're going to be using a small sort of green ogre type guy for our enemy. So in the folder on my desktop, I have all these images, and I'm just going to go ahead and copy this folder and paste it back into my file tree where my game is. So let me go ahead and paste. Alright, so let me go ahead and paste. Okay, so here we are. We have our enemy images in our file tree. And the first thing we're gonna need to do is we're gonna need to load in the images. Now, since this is quite a tedious thing to write, and we've already done it in the previous tutorials for our hero, which was this guy. I'm just going to go ahead and copy the code for our enemy just to make sure we're not losing any time. And if you want a more sort of detailed instructions on how to load images into Pygame, make sure to check out the tutorial on animating a character in this tutorial series. That's where you'll learn how to load in images. So let me just quickly go ahead and copy these images in. Alright, so over here when I expand the code, you'll see that what we've done here is pretty much the same as we've done for our hero. So we're going to call the variable left_enemy. This variable is going to store all the images of our enemy moving to the left hand side, such as this one, for example, or this one. And the other variable is going to store all the images of our enemy moving to the right. So let me go ahead and minimize them, and just to give this a little bit more structure, I'm going to give it subheadings. So over this, there's going to be, this is going to be the pictures for our enemy, so I'm going to write enemy over on top. Then below that we have the images for our bullet, and below that again we have the background image, so I'm going to say background. And above that we have the images for our hero for our player, which we control. So I'm just going to put that in parentheses, player, because that's the ones that we control. And there's actually one image which I can remove because we're not using it anymore. And that is the one of our hero standing still, which is this one. Since we're not using it anymore, I'm just going to go ahead and delete it just to make the code less clunky. There we go. So now that we've loaded in the images, the next thing we want to do is somehow get the enemy shown up on our screen. So we're going to go ahead and create a new class and call it enemy. Alright, so our enemy is going to get an init method first, so define _init, and we are going to pass in several parameters. We're going to pass in the coordinates of where we want our enemy to spawn, and that is going to be an x coordinate and a y coordinate because it's a 2D game. And we're going to say self.x is equal to x, and self.y is equal to y. Okay, having done that, we then want to we want to create another method which draws the enemy onto our screen. So we're going to say define draw. And the draw method is going to take a additional parameter, which is going to be the win. Win is short for window, and it is the variable we defined at the very top of our file over here. Window is basically the screen where we print out the images. It's basically the canvas or the surface where we play our game. So I just went ahead and called it win, short for Windows, window, pardon, and that is going to be the draw method. So the next thing we want is to, of course, win.blit an image onto the screen, and we're just gonna go ahead and simply sort of draw one of these images. Let's just take the first one with index 0, just to show you guys what we're about. So then in addition to that, we also need to tell the draw function where exactly we want the enemy to be drawn, and we of course want the enemy to be drawn at the xy parameter that we pass in. So over here we're going to write self.x, self.y. Okay, so that's that, and that should do for the moment. So the first thing we just want to do is somehow print an enemy onto our screen. So now we want to go ahead and create an image of our enemy on the screen. So I'm going to create an instance of the class. I'm going to call this instance of enemy class, and I'm just going to make it an empty list and call it enemies. The reason why I'm making an empty list for this is because we perhaps want more than one enemy to be there. So just to leave us that option, I'm going to make a list for if we want to add more than one. So I've went and minimized our while loop. Let me go expand it again, and over in the main loop over here, we want to add a sort of subsection for our enemy, and we're going to say that if the len of enemy, if the length of the list enemies is equal to 0, then we want to go ahead and create a new instance of the class enemies and store it in the enemies list. So we're going to write enemy is equal to enemy, and we're going to pass in the parameters, and we're going to spawn this enemy sort of at the right hand side of our screen. So that's going to be somewhere like 700, and the y coordinate is going to be something like 300. I looked at this before. This should more or less do the deal. And of course, after we've created the enemy, we want to append it to the list of enemies. So enemies.append, and then we want to append the object enemy. Okay, so now that we've sort of gone ahead and, well, created our enemy in the main loop, we want to now also draw the enemy. And since we've put all the stuff concerning the drawing of the game into a separate function, we're going to add the drawing of our enemy to this function too. And this is going to be really easy. We're just going to say that for enemy in enemies, so for an object, so for a list element within the list enemies, we're going to enemy enemy.draw, and we're going to draw it in, and we have to pass in one parameter, which is the window. Okay, so this should do the deal now. Let me go ahead and run this and see where we stand. All right, yeah, so this looks good as a first step. Wait, let me go ahead and open it again. We have our enemy over here, which is sort of being shown, and we still have our character and everything's working fine. Now, the next thing we want to do is we want to move the enemy across the screen, and we also want to animate the enemy. So that's the next step. Okay, so let's make our enemy move across the screen. To do that, we're going to go to our enemies class, and we're going to create a new function. We're going to say the function is going to be called move, and all it's going to do is it's going to decrease the x value, the x coordinate of our character by 3 pixels. And we want this decrease to happen, this decrease in x value to happen every while loop iteration. So we're going to say that in our enemy in the main loop, so the main loop begins up here, remember, we're going to say that for enemy in the list of enemies, we are going to call the function which we've just created, which was move. So I think that should do the deal. So we have our enemy over here with our enemy class, with a new function we've just defined called move. And in addition to that, we've just made a call to the function in the main loop. So now what should happen is that our enemy should move across the screen, and he does, which is exactly what we want. So now the last step that remains is that we need to somehow animate this small goblin, similar to the way we animate our main character, which I'm controlling right now. So let's go ahead and do that. Since we've already covered the topic of character animation in the 6th tutorial of this series, this should be quite an easy task to do. So the images for our enemy are already loaded in these lines of code over here. We have the images of our enemy showing to the left given here, and the images showing to the right given here. So moving down into our enemy class, we now need to make sure we somehow iterate through these images successively to make our character seem animated. And we're going to say that the image which is going to be printed out or shown on our window is going to be self.stepIndex. So if you've watched the 6th tutorial on character animation, you'll already be familiar with the variable stepIndex, which I introduced. The variable stepIndex is simply a variable which is runs through the list of images and sort of successively shows each individual image index. And by default, we're going to set the step index equal to 0, because at the beginning we want this image to be shown, which has the index of 0 in our list. Okay, so now we somehow need to increment the step index plus equals 1 plus equals 1. Okay, and we need to write self.stepIndex, of course. So we're incrementing the step index, and one thing we need to watch out is that once the step index reaches the highest possible index, we need to reset the index. And in our case, the highest possible index is going to be 11 because we have 11 images stored for each direction. So if I go to my file tree, you will see that on the left-hand side over here, I have 11 images which have an L in front of it, and that shows our character facing to the left. Similarly, I have 11 images showing to the right. So we are going to make sure that once our step index reaches the value of 11, we reset it. So we're going to say if self dot step index is greater than or equal to 11, then we want to self dot step index and we want to reset it to 0. And of course, we need to make sure that we're calling this method in our draw function. So self.step. Okay, so let's see if this works. Yep, our small goblin is in fact animated, but at the moment you can see that the movement is a bit jagged. It's sort of a bit stiff and jagged. And the reason why is that each image is being displayed for one while loop iteration. And since the while loop is running really quickly, we need to adjust this and make our images be displayed for longer than one while loop iteration. And so we could, for example, increase the step index to 33 and then floor divide our self.step index by 3. So now every single image of our goblin that we have, so all these images which I've shown you before, all these images get shown for 3 while loop iterations. And now if I go ahead and run it, you'll see that it looks much more smooth. Yeah, now it runs a little bit slower and much more smoothly than it did before. All right, so now there's a couple more things we need to do, which is we need to delete the enemy once it moves off screen, and we want enemies coming from both sides. So that's the next step. Okay, so deleting the enemy off screen should be done quite easily. We'll implement another function and call it off screen. And it is going to tell us whenever an enemy is off of the screen. So it is going to return, and then it's going to return not, and then we have to pass in the area on screen. So self.x is greater than or equal to 0, and self.x is smaller than or equal to the window width, window underscore width. Okay, then we need to, of course, call this function for all the enemies. We're going to say that if the enemy dot off screen is true, then we want to remove the enemy from the enemies list. Remove enemy. Okay, now let's go ahead and run this and see if it works. So you can see our enemy is walking to the left-hand side of the screen, and at the end of the screen he should disappear. So it's going to happen any moment, and he's gone, and then he resets. But one thing we should make sure is that the enemy walks off the screen entirely before being removed. So let's go ahead and change the off-screen function and say that he can move to an x value equal to -30 before being deleted. I think it just looks a little bit nicer. So let's go ahead and run this now. And you'll see that the enemy walks off the screen entirely on the left-hand side before being deleted. So let's see if that's going to happen. He's walking, continues, and then yeah, he walks a bit further before being deleted, which is quite nice. Or I might even go ahead and increase that to -50 just to make sure that he walks off entirely. Okay, so now to make enemies spawn on both sides, we need to go ahead and make some adjustments to our main loop over here. We're going to say that the first thing. Okay, so deleting the enemy off screen should be done quite easily. We'll implement another function and call it off screen. And it is going to tell us whenever an enemy is off of the screen. So it is going to return, and then it's going to return not, and then we have to pass in the area on screen. So self.x is greater than or equal to 0, and self.x is smaller than or equal to the window width, window_width. Okay, then we need to, of course, call this function for all the enemies. We're going to say that if the enemy dot off screen is true, then we want to remove the enemy from the enemies list. Remove enemy. Okay, now let's go ahead and run this and see if it works. So you can see our enemy is walking to the left-hand side of the screen, and at the end of the screen he should disappear. So it's going to happen any moment, and he's gone, and then he resets. But one thing we should make sure is that the enemy walks off the screen entirely before being removed. So let's go ahead and change the off-screen function and say that he can move to an x value equal to -30 before being deleted. I think it just looks a little bit nicer. So let's go ahead and run this now. And you'll see that the enemy walks off the screen entirely on the left-hand side before being deleted. So let's see if that's going to happen. He's walking, continues, and then yeah, he walks a bit further before being deleted, which is quite nice. Or I might even go ahead and increase that to -50 just to make sure that he walks off entirely. So now spawning in the enemy from both sides is going to be what we want to implement. So the first changes are going to be made to our main loop. We're going to say that if the length of the enemies is equal to 0, we're going to first create a random number, and the random number, we first need to import a module to generate random numbers. So we're going to import random at the top. And then we are going to create a random integer, random.randint, and it is going to be between 0 and 1, or more specifically, it's going to be 0 or 1. And we're going to say that if the random number is equal to 1, then we want to spawn the enemy on the right-hand side of our screen. So let me go ahead and just change the indentation here and here. And we need to make sure that the x value corresponds to the right-hand side of our screen. So we're gonna, since the window has a width of 800, we're gonna spawn our enemy at the x value of 800, or maybe not entirely 800. Let's do it 750 first. So it's going to spawn somewhere on the right hand side. And if the random number is equal to 0, then we want to spawn the enemy on the left hand side. So we're just going to copy these two lines of code, paste them in here, and we're going to change the x value of where the enemy spawns. Let's make it 50. Okay, so after we've done that, we also need to pass in another parameter, which is the direction in which the goblin is facing. So when the goblin is moving to the left, he is going to be, of course, facing to the left. And so we're going to pass in another parameter. And we'll adjust the enemy's class in a moment. And if he spawns on the left-hand side, he's going to be facing right when he moves to the right. Okay, so now we have adjusted this and that. And the next thing we want to adjust is the enemy class. We're going to say that hold on, we want to now make the following adjustment, which is that we're going to have another parameter or another variable in our init method. We're going to say that self.direction is equal to direction, and we're going to add direction to the parameters which are passed into the init method. Okay, so we have that, and we're going to use direction in the draw function. We're going to say that if self.direction is equal to left, then we want to have the images which show our character moving to the left be displayed, and if self.direction is equal to right, then we want to have the images which show our character to the right be displayed. So let me copy. The adjustment we need to make is here. Instead of saying left underscore enemy, we want right underscore right underscore enemy. Okay, so let's see how that plays out when I go ahead and run it now. Okay, so our character is moonwalking off the screen on the left-hand side. Well, let's see if he does that again, just to show you what the problem is at the moment. Oh yeah, there you see it. He's moonwalking off the screen, and that is because I still need to change the move function. We're going to say that if self.direction is equal to left, then we want to decrease the x value of our character's coordinates, and if self.direction is equal to right, then we want to increase the value of x for our character. Now it should work just fine. Let's see if it does. So we have our character who has now been spawned on the right-hand side, moving to the left, and he's animated. And let's hope that he spawns on the other side now. Yep, he spawned on the other side, and you can see him walking really nicely off the screen. And he should be deleted at the end of the screen, I hope. Or does he carry on walking? No, he gets deleted because a new enemy is spawned. Yeah, so that looks nice. One small adjustment we're going to make is we're going to adjust the off-screen function, and we're going to say that the window, the place where the enemy is deleted is just off the screen, so we can make sure that our enemy walks off the screen entirely before we delete him, and that should be the only change for now. Alright, so we're going to leave it there for this tutorial. We've managed to create a small enemy, and the next step is going to be creating some sort of hitbox and health mechanic to make this game more complete and to have them fight each other. So if this tutorial helped you out, make sure to leave this video a like and consider subscribing to this channel if you are new, and we'll see each other in the next video.